Hello YouTube, this is Joseph STEM APKs. Welcome to another tutorial. This tutorial we're going to be working with PPM files. For those of you who do not know what PPM files are, back in the day PPM files were very popular, especially it's by the way what it stands for is portable Pixmap format. And like I said, they came out in the late 1980s, and you still see them, but mostly now for to store basic color, very basic color images, and also exchanging image information. That's why we're using them. That's why I'm making this tutorial is because I'll be using them as we transfer data, RGB data from images from the computer into the Raspberry Pi or any other embedded system, or from the embedded system or the Raspberry Pi back into our computer. So it's going to be, uh, it takes a file like a compressed file like that uses PNG or JPEG compression, converts it into PPM, which is the intermediary file, and it converts it back into a compressed format. So I'll be using them, and if you've never heard what a PPM file, you might be saying, "What is that?" Well, that's why I'm creating this, and they're very easy to write. The only issue with PPM files, you will need either GIMP. I'm using GIMP, which is open source, is free. You can download it into your computer, or you can use Adobe Photoshop, but as you know, it's not free. So that's why I'm using GIMP. You cannot just open it with any other, with just anything out there. It has to be very specific. So let's write I just did this very basic file just to give you an introduction. It's basically a red gradient, as basic as it gets. And just to explain to you, is using the input output because we're writing into a file. We're using from the standard also the file system because we're going to be creating files, as you can see. And here, this is the main function with the width, the height, and the max color. And that's what we're going to be using in this guy, the header. Okay, so this is a P3 header, it's very basic, but I'm going to be showing you a P6 as well. And this is why you need that is to create this header right there. And it's going to have three pieces of information. It's going to have a P3, the header name or type, the width, the height, and the maximum color. Here is going to generate the pixel data. This is a synthetic image. So it's going to be the outer and the inner loops for the height and the width. And it's just creating, being that it's a gradient, is dividing by the width and times the white, the 255. And on sign, also on sign 8. So that's what's happening here. And we're keeping blue constant, so it's just going to be red and green and keeping blue constant. And as you, let's just run it here. And we run it, and this image was created, and it's this one right here, output. And if we open it, this is the output. It's going to be the P3, a 3 by 2 matrix with the maximum color of 255, and then the data. This is the data. Okay, 3 by 2, 1, 2, 3, 4, 5, 6. But that's not fun. That's just text. That's the intermediary stuff for the RGB values, right? But if you want to look what they look like, that's where GIMP comes to the rescue, and this is what it looks like when you open it using GIMP. And as you can see, I created another one. It's this checkerboard, and if you open this one, let's open it here really quick, and just to give you an idea, same thing, very similar, but now here besides the maximum color 255, we also have a square size, um, which is here, and it's going to create the the shape here, as you can see, this shape, and you can see it's 1, 2, 3, 4, 5, 6, 7, 8, and then by 8. So it's going to be, this is where this is created. It's going to be black and white. So there's only black 0, 52, 55, and it's going to do create the name. It's going to be checkerboard, I believe it is. Yeah, checkerboard. You can change it whatever you want it to be. So if we run this now, we create this file, which is the checkerboard right there. If we try to open it, this is not this ASCII anymore. Now it complains. Okay, so you need GIMP in order to be able to open it. And now let's do something more interesting, because let's add some color, because right now the, the checkerboard was just 0 and 255. So let's just add some color so you can see it. And it gets a little bit more complex, but basically the same, the FS, the input output, but here now we're introducing the create random to generate random numbers. And we're also here, the FS file, let's talk about it, allows the file creation and manipulation, self and write. It is required for writing data to files, just like we saw before. And here, as you can see, it imports the random trait, which provides the methods for generating random numbers. And here now you see them as we create. It declares the main function, returning input output result. And if, as you can see here, where is it? Oh, it's right there. So it's going to complain if an error occurs, like for example, if there's a failure in the creation of the file, it will propagate. And so now here we're defining the image properties, the width 256, height 256, maximum color 255, just like we did before. But now here we're initializing the random number generator, and that's what's happening here. It initializes a random generator specific to the current thread. Now, because remember, we're working here with threads. This will be used to generate random RGB values for each pixel to create the noise. The headers, same thing again, is P6, width, height, max color. And the loop, where the magic happens, this is where basically it's iterating width times height, basically 256 times 256, it will be 65,000 times once per pixel. And here, as you can see, is 0 to 255 for each of the colors, and it's going to be completely random. Uh, these are the RGB values, the red channel, the green channel, the blue channel. And each pixel will have a completely random color, creating static noise effect. That's what we're looking for. And basically here, all this stuff, is writing the RGB values as raw binary, 3 bytes per pixel. And since we're using P6 instead of P3, this is more efficient than just writing ASCII values. And when we run this one, instead of that one, what did I call it? Random noise. So now random noise, and you run it, you create this image right here, noise PPM. If you try to open it, it complains. So we need GIMP. We go to File, Open, and then Noise. And you can see it creates this beautiful random noise, that is static effect. And that's what we're doing. Now we also have, I, I, I'm going to put all of these in my GitHub, and just in case, I want to show you the cargo toml file, because we used these before to create the network analyzer, but now we needed these two new ones, for the random generator and the image crate, that if you watch some of my other tutorials, you're very familiar with it. And that's where what the cargo toml looks like. Let's do a convert, and here it gets a little bit more complicated, more complex, but it's basically same, very similar. Now we're using the image crate here, because we're using the generic image view that we did in one tutorial before. Basically what we're going to be doing is taking a PNG image and converting it to PPM. That's what we're going to be doing here. This is very similar to what you've seen before. The difference here is the generic image view. This is a trait that it provides all the methods to access image dimensions and pixels through the image crate. Dynamic image, it represents images that can have various color formats. Okay, and as you can see, these are some of them. And that's the enum right there. If you watch my other tutorial series, I get it more in detail into these. Here, same thing, we're creating the output image, the header, just like we did before, nothing new. This is where the iteration is going on between, basically, let me see here, before we get there. This is writing into it, the header, write the RGB, just like we did in the last one. But in this case, let me, as you iterate between the pixels, here, instead of X and Y, they're being ignored, as you can see. So this would normally be X, Y, and the pixel, and it's going to be our red, green, blue, or the alpha channel. But in this case, the underscore, you're able to basically ignore them. Let's put it that way. Just like here, we're ignoring the alpha channel, and that's what's happening there. And basically, the pixel 0 here, it contains 4 values, the RGB A. But like I said, we're ignoring the alpha. And because the reason that we ignoring it is because PPM does not support it. So you know. And basically, we're doing just like we did before. We're writing into the file. We're basically writing the 3 bytes RGB per pixel to the file in binary format, just like we did before. And the P6 PPM file will store all the RGB values as raw binary. So it's a good way to store pixel data. And that's now we're going to convert. So let's convert that one, cockfight PNG. You've seen it before. So instead of, oops, wrong thing. It's here, the other one. What did I call it? PPM convert from JPEG. It's not from JPEG, it's actually PNG, but it's okay. It's a proof of concept. What is the real name? To PPM. PM. And we don't need the RS. And it gave an error because it didn't like something here. Failed to open an image. Let me see here. And the reason that it's not working is because there was no cockfight PNG file. So I forgot. So this is optical JPEG. That's the image. So if we, instead of changing it, I changed it from the cockfight PNG and I basically optical JPEG, which is this file right here. Let's just look at it. And now we're going to convert that one. So let's just run it. And now it created this image, which it should be output PPM. So if we try to open output PPM, as you can see, it's got the header and some weird stuff. Okay. But now we use GIMP to the rescue and we open the output PPM and there it is. And now you have your PPM image that is not compressed. Remember, this is raw. So it's very handy in certain situations. Not all the time, but in certain situations can be very handy, and we're gonna be using them as we transfer images from embedded systems or Raspberry Pi into our computer, and also from our computer to the Raspberry Pi or other embedded systems. But this is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Take care.